All right, students. This is Campus Academy. That specializes in physics, chemistry, maths, further maths, and technical drawing. We want to continue from where we stopped. I started the solutions to NECO 2021, the one that was written on the 28th of July. On the 28th of July, okay, here in Nigeria, NECO is National Examination Council. So I started with the objective part. I was able to solve 1 to 20. 1 to 20. So I termed that part 1. So today we'll continue from number 21. As you can see, this is a past question. We'll continue from number 21. And please don't forget to click on the subscribe button so that you can see other videos I've uploaded on physics, chemistry, maths, further maths, technical drawing, and all that. Okay, so don't forget to click on like button and subscribe button. When you click on subscribe button, you'll be able to see other videos. Don't forget, this is Campus Academy. So you can chat me up on 090-745-26311. That's my WhatsApp number, that's my phone number. And don't forget, you are equally into home tutoring. Okay, 090-745-26311. So we are equally into home tutoring. We'll be there live wherever you are. Okay, all right. Let's see how far we can go from number 21. So your understanding in this particular chemistry we enable you to pass the WAEC that is coming up in the next 1 month, West African Examination Council, as well as JAM and other international exams. Okay, so I'm going to break it down step by step. I'm going to explain in such a way that you understand. So, all right, let's start from. Please, you can click on subscribe button so that you can see the previous videos from number 21. The question says, what percentage by mass of sodium is present in the compound Na2CO3? So let me write it on the board. Na2CO3 dot 10H2O. So what percentage of sodium is present in this compound? This is sodium carbonate decahydrate. Otherwise known as washing soda. Okay, how do we calculate the percentage by mass of sodium? You first of all calculate the molar mass of everything. So molar mass of all the elements, molar mass of the compound. How can you calculate the molar mass of the compound? You have the atomic masses of the elements. You have the atomic masses of all the elements given. Are we there? We have been given sodium as 23. Sodium is 23 from the question. So, but the sodium is having a subscript of 2. So that's 2 times 23 plus. Then the next thing is carbon. We have only one atom of carbon. So the atomic mass of carbon is given as 12 plus. Now we have 3 atoms of oxygen. That is 3 times atomic mass of oxygen is 16. Is given in the question. Then now this dot, you're not going to multiply it either. This dot 10H2O, you're not going to multiply it. That dot means that you still add. Okay, your addition continues. Okay, then 10. This is 10 into bracket. We have 10 molecules of water, right? So this 10 is multiplying the atomic masses of the addition of hydrogen and oxygen. Is that taken? But this dot means plus here. After which you now write 10 molecules of water, which is 10 in bracket. So hydrogen, we have 2 atoms of hydrogen. Are you there? That's 2 times. What is the atomic mass of hydrogen? It's given as 1. Okay, that's 2 times 1. Okay, then plus atomic mass of oxygen is 16. Then close bracket. So we have all this one as 46 plus 12 plus 16 times 3, 48 then plus 10 in bracket 2 times 1 2 plus 16. Okay, so we have this. Let's add everything together. So we have 40. We have so we have 46 plus 12. Okay, plus 48 plus 48. That gives us 106. So this one is 106 plus 10 in bracket 2 plus 16 is 18. So we have 106 plus 180. 10 times 18 is 180. So 106 plus 180 we give you 286. So 286 gram per mole. So that's the molar mass of sodium carbonate decahydrate Ne2CO3.10H2. Now, how do you now calculate the percentage of sodium inside? They say we calculate what? So we calculate 21. What percentage by mass of sodium is present? Sodium. So now go back. Sodium, we are having 2 atoms of sodium. 2 atoms of sodium. So percentage by mass of sodium will now be the atomic mass of sodium. The atomic mass of sodium. So and it, sodium is having, we're having 2 atoms of sodium. So that's going to be 2 times what's the atomic mass of sodium? That's 23. So all over the molar mass of overall. Molar mass of overall is what? 286. So when that gives us 2, that's 46 times 100. Don't forget times what? 100. Okay. So and that gives us 46 over 286 times what? 100. So 46 over 46 divided by 286, then multiplied by 100. That gives us 16.08. That gives us 16.08%. Okay, that is our final answer, 16.0. So the question says, what percentage by mass of sodium is present in the compound Ne2CO3.10H2O? We are given sodium as 23, carbon as 12, oxygen as 16, hydrogen as 1. Option A 4.20, option B 8.04, option C 16.08, option D 23.00, option E 80.40. So option C is the correct answer, 16.08%. That's 121. Option C is the correct answer. So let's go to number 22. Number 22 is not a calculation question. It's not a calculation question. 22. In the extraction of iron, which of the following reactions does not take place in the blast furnace? Oh my goodness. In the extraction of iron, which of the following reactions does not take place in the blast furnace? A blast furnace is used to produce iron from its ore. Okay, and I've told you in part 1, this is 1 to 20 of these particular questions, that there are 3 major materials that are used. There are 3 major materials that are used in the production of iron in the blast furnace, and they are we have the iron ore itself. The iron ore itself, either we can be hematite or magnetite, as the case may be. Then we have iron ore. We have the coke. Then we have limestone. We have what? Limestone. We have limestone. Okay. So what are the reactions that occur in the blast furnace? First and foremost, you see this limestone is calcium carbonate. Are you there? That is calcium carbonate 4. It will decompose either under the action of heat. Heat will make it in the blast furnace. It's very hot. It's going to make it decompose into calcium oxide plus carbon 4 oxide. Okay, that is one of the reactions there. Are you there? So the carbon 4 oxide gas, are you there, will be attacked by coke. Coke is carbon. So, and that gives us the carbon, which is coke, will reduce the carbon 4 oxide to carbon 2 oxide. Chinekimi. So this carbon 2 oxide will now come and reduce the iron ore. The iron ore could be hematite. That is Fe2O3. So the Carbon 2 oxide is a powerful reducing agent that will reduce the iron 3 oxide into iron plus what? Carbon 4 oxide gas. Are you there? Another reaction is this. You see this calcium oxide that is left, that is one of the products of the decomposition of calcium carbonate. This calcium oxide, are you there, will react with acidic impurities. The acidic impurities that that comes, one of the acidic impurities that comes with iron ore. You know, ore. The ore means that it's an the ethylene impurities come along with the ore. So one of the impurities is silicon 4 oxide. Okay, silicon 4 oxide. So calcium oxide will now react with silicon 4 oxide, that you also know as silica. Oh my goodness. So you come to form calcium silicate, calcium triazo silicate 4. Are you there? So we have calcium silicate like that. Okay, calcium silicate. So now these are the reactions that we have in the blast furnace. Okay, now let's see option A. Option A says, question says, in the extraction of iron, which of the following reactions does not take place in the blast furnace? Does not take place. So option A, CaCO3 to give CaCO3 to give CaO plus CO2. We have that, CaCO3 to give CaO plus CO2. That one is correct. Option B, CaO plus SiO2. CaO plus SiO2 to give CaSiO3. We have that here. Then option C, CO2 plus C to give 2CO. CO2 plus C, are you there, to give CO or 2CO. So you have to balance all the reactions. You know, it is a sin to write an unbalanced chemical reaction. It is better not to write a reaction than to write an unbalanced chemical reaction. Every chemical reaction must be balanced. Do you understand? So you balance all these. So I don't waste time in balancing chemical equation. I just root out the reactions like that. Okay. Now that we have option C is there, which is this. Then option D, 2Fe2O3, as in 2 moles of Fe2O3 plus 3 moles of carbon. 2Fe2O3 plus 3 moles of carbon to give 4Fe plus, that one is not there. Carbon does not react with the Fe2O3. It is carbon 2 oxide. Look at option E. Fe2O3 plus 3CO. Fe2O3 plus 3CO to give 2Fe plus 3CO2. That's when you balance this one, when you balance this particular reaction. So this one is there. Option E is correct. Option A is correct. Option B is correct. Option C is correct. It's option D that is wrong. Option D, the roots are Fe2O3, that is 2 moles of this reacting with 3 moles of carbon to give 4 moles of iron plus 3 moles of carbon 4 oxide. So it is not carbon that reduces the iron 3 oxide to iron. No, it is carbon 2 oxide that does that. So option D is wrong. For number 22, option D is wrong. Now, number 23, let's see how far we can go. Number 23, the metal that can be extracted from cassiterite. Oh, cassiterite. Cassiterite is tin stone. Okay, cassiterite is tin stone. That one of the ores of tin, tin SN. Okay, cassiterite. Okay, so the metal that can be extracted from cassiterite is option A, aluminium, option B, calcium, option C, copper, option D, magnesium, option E, tin, tin. The symbol is SN. Okay, SN is that taken. So that's one of the ores of tin is cassiterite or tin stone. Number 23 is E. 24. The added form of carbon is O. The added form of carbon. The added we have option A as charcoal, option B coke, option C diamond, Option D, graphite. Option E, wood. We have different allotropes of carbon. We have crystalline allotropes of carbon and the non-crystalline allotropes of carbon. The crystalline allotropes of carbon are diamond and graphite. While the non-crystalline allotropes of carbon are the wood charcoal, sugar charcoal, lamp black, and all that. Do you understand? So out of the crystalline allotropes of carbon, which is diamond and graphite, diamond is the hardest known. So diamond is the hardest form of carbon. Diamond is the hardest form of carbon. So option A, charcoal. Option B, coke. Option C, diamond. Option D, graphite. Option E, wood. So option C is the correct answer, diamond. Take a paper and pen and begin to jot. Okay. Number 25. The ability of carbon atom to form long chain. The ability of carbon atom to form long chain or ring is known as, oh my goodness, ability of carbon atom to form the ability of carbon atom to form long chain or ring. You see that in organic chemistry. Let's look at the options first. Option A, benzene ring. Option B, carbonization. Option C, catenation. Option D, centrifugation. Option E, polymerization. No. So but it's not called benzene ring either. It's not called benzene ring. Option B, carbonization. Benzene ring is like this. That's benzene ring, which is C6H6. Okay, so that's not the option. That's not the correct option. Option B, carbonization. Carbonization, that's the process by which a carbon atom is added to a chemical substance. When carbon is added to a chemical substance, then we can also have decarbonization, removal of carbon. Carbonization, addition of carbon. Okay. Option C, option B is wrong. Option C, catenation. That is the ability of carbon atoms to form long chain or ring is known as catenation, the ability of carbon atoms to form a long chain or a ring. You see that in organic chemistry, and it is this the ability of carbon atom to form a long chain that brings about the existence of organic chemistry as a separate branch of chemistry. Okay, that's one of the reasons, right? So, and we also have another reason for the existence of organic chemistry is the ability of carbon atoms to also form single covalent bond, double covalent bond, and triple covalent bond and all that. Okay, so it's not only carbon that can catenate, silicon can also catenate. Are you there? And that ability of silicon to catenate is found in silicone. Okay, so carbon can catenate more than silicon. So catenation, that's the spelling, catenation. The ability of carbon atoms either to form a long chain or a ring chain or a ring. Number 26. An acid is a substance which in the presence of water produces. Oh my goodness. Option A, carbon 4 oxide. Option B, chlorine gas. Option C, hydrogen gas. Option D, hydrozonium ions. Option E, salts. From the definition of acids, according to Arrhenius, are you there? According to Arrhenius, an acid is a substance which, when dissolved in an aqueous solution, produces hydrogen ions as the only positive ions. Either. So an acid is a substance which, when dissolved in an aqueous solution, produces hydrogen ions as the only positive ions. So it could be produces hydrogen ions or hydrozonium ions. Produces hydrogen ions or hydrozonium ions, or you call it ozonium ions. Either hydrogen ions or hydrozonium ions. Is that taken? So this, what happens is this: when you have an acid like maybe hydrochloric acid, it ionizes either in the solution to give hydrogen ions plus what? Chloride ions. Are you there? So you know the acid is inside water. It means that aqueous solution means that it is with water. Are you there? So these hydrogen ions, okay, will react with the water molecules. Will react with the water molecules to give hydrozonium ions. That is H3O plus. H3O plus hydrozonium ions. So if you define your definition, if you define acid as a substance which when dissolved in aqueous solution produces hydrogen ions as the only positive ion, you are right. If you define it as produces hydrozonium ions, which is H3O plus as the only positive ions, you are also right. Okay, so our options. You want to say an acid is a substance which in the presence of water produces option A, carbon dioxide, option B, chlorine gas, option C, hydrogen gas, option D, hydrozonium ions, option E, salt. So our correct answer is what? Hydrozonium ions, which is H3O plus. Is the taking? That's number 26. Let's go to number 27. Don't forget that we are still going to seeing going to upload videos on the theoretical aspect of it, okay, of this examination, NECO Chemistry. 27 now. 27. Oh, 27 is a calculation question. And 27 is a calculation question. So we gotta calculate. Yeah. Number 27. A hydrocarbon X, okay, with a molar mass of 26. A hydrocarbon X with a molar mass of 26 consists of 92.3% carbon. A hydrocarbon X with a molar mass of 26 consists of 92.3% carbon. What is its molecular formula? What is its molecular formula? A hydrocarbon X with a molar mass of 26 consists of 92.3% carbon. What is its molecular formula? Yeah, we can use a table to solve this. Are you there? A scatter table to solve this. So we have elements. So the elements are, they say hydrocarbon. An hydrocarbon substance contains only hydrogen and carbon only. It contains hydrogen and carbon only. Hydrocarbon is a substance that contains hydrogen and carbon only. So the element will be carbon and what? Hydrogen. Okay. Then this element. Then percentage by mass. They said a hydrocarbon X with a molecular mass of 26. We also come to that. Consists of 92.3% carbon. That 92.3% is the percentage by mass for carbon. For carbon, 92.3%. Is it the percent again? Okay, 92.3. That's the percentage by mass of carbon. Then we are not given the percentage by mass of hydrogen. But since we know that the compound contains carbon and hydrogen only, so if you have 92.3% as for carbon, that means the remaining one is for what? Hydrogen. That means the remaining one is for hydrogen. That is 100. So that will be 100 minus 92.3. We give us 7.7. So 7.7 is the percentage by mass of hydrogen. The remaining one, you subtract this one from 100. Okay. So after percentage by mass, okay, the next thing will be atomic mass. The atomic mass of the element. We are given in the question that the atomic mass of carbon is 12. Atomic mass of hydrogen is 1. Okay, so after that you have number of moles. I know the formula of number of moles. Number of moles is equal to mass over atomic mass. Number of moles is equal to mass over what? Atomic mass, as far as an element is concerned. So the mass is the percentage by mass. Are you there? Why this one is atomic mass? Number of moles is equal to mass, which is that percentage by mass over atomic mass. So mass is 92.3 over 12, and this one is 7.7 over 1. Okay, So 92.3 divided by 12, that gives us 7.69. 7.69. Are you there? 7.69. Okay, you approximate it to 8, having as 8 7.69. So that's 8. That's 8. Okay, then we have 7.7 divided by 1. 7.7 divided by 1 approximately is also what? 8. Okay, 7.69 for this one. 7.69, you can't have decimal point there either. You approximate the whole number, that's 8. Then 7.7 over 1. 7.7 over 1, that one is also what? Approximately 8. Okay, that's 8. So, and 7.69 means 7.7 also. 7.7 to one decimal place. 7.7. So, now, or maybe we should leave it at 7.7. 92.3 over 12 give us 7.69. Are you there? Which is 7.7. Which is 7.7. 7.7. Okay, so 7.7 over 1 also 7.7. Okay, that is that for that. Then we now have mole ratio. Mole ratio. For the mole ratio means that you divide the you use the smallest number to divide all. The smallest number or the smaller numbers. If you have two elements, now the smaller number. So no one is smaller here, everything they are just the same thing. So now it will now be 7.7 over 7.7. Then 7.7 over what? 7.7. Okay, but if we have maybe we have 2 here. 2 is smaller than 7.7, so it's going to be 7.7 over 2. Then 2 over 2. Is that okay? So you use the smallest number or a smaller number to divide. But in this case, we're having the same number. So that at the end of the day, we have it as 1 and 1. Okay, so the empirical formula, in case we have to calculate the empirical formula, so will now be carbon subscript. How many? What's the final answer here? 1. Is it? Okay, then hydrogen. What's the final answer here? 1. So C1H1, which individually means CH. Okay, if you are asked to find the molecular empirical formula, so the answer will be CH, carbon with hydrogen. Is that taken? But we are not asked to find empirical formula, we have to find molecular formula. You're not continuing from here. Okay, now continuing from here. So the molecular formula, then you now look at for us to get the molecular formula from the empirical formula, so we have to look at molecular mass or molar mass. Okay, so molar mass. So the molecular formula first, if CH is the empirical formula, molecular formula will now be CH, either subscript N. So N is an integer, either 1, 2, 3, 4. So we don't know what N is. We don't know whether it's 1, whether it's 2, whether it's 3, whether it's 4, whether it's 5. So this is the molecular formula. So let's go and calculate the molecular mass of the CH subscript N. So molecular mass is calculated by addition of the atomic masses of each of the elements. Addition of the atomic masses of each of the element multiplied by the subscript multiplied by N. So we now have carbon. Carbon is what? Carbon is 12. The atomic mass of carbon is 12. Is given multiplied by N. Are you there? Then plus atomic mass of hydrogen is given as 1 in the question. 1 multiplied by N. Is that taken? So all equals to this particular line means you are calculating the molecular mass or molar mass. And if you look at the question, it said a hydrocarbon X with a molar mass of 26. So we have given the molar mass as 26. So all this equals to what? 26. Let's now solve. So we now have 12N plus N equals to 26. That's 13N. 12N plus N is 13N equals to 26. Make it n is subject. So n equals to 26 over 13. N equals to 26 over 13, and that has given us 2. So n is 2. N is 2. So n is 2. So 26 over 13 is 2. So now, for us to get the, now go back and substitute the value of n as 2 here. You go back and substitute the value of n. You know we have ch subscript n. So what value of n? Ch subscript what? 2. So are we together? Now it means that this carbon takes 2, this hydrogen takes 2. So you split them. So we have carbon subscript 2, hydrogen subscript 2. Oh my goodness. This is what? Ethine. This is ethine. Ethine. Are you there? Ethine. E-T-H-Y-N. That's ethine. And ethine is the first member of alkyne. Alkyne as one of the molecular series in organic chemistry. So let's look at the option. Option A, C2H2. That's our answer. Option B, C3H3. Wrong. Option C, C4H4. Wrong. Option D, C5H5. Wrong. Option E, C6H6. Wrong. So the correct option is option A, C2H2, ethine, for number 27. Okay. All right. We are progressing gradually. Don't forget that chemistry is water and water is life. Chemistry is life. Okay. All right. Don't forget this campus academy where we make everything simple. All right, number 28. The component of universal indicator solution. The component of universal indicator solution can be separated by. The component of universal indicator solution can be separated by option A, chromatography. Option B, crystallization. Option C, distillation. Option D, evaporation. Option E, filtration. Everything is just shone. Oh my goodness. So let's begin to analyze the options one after the other. Chromatography. Yeah, chromatography. Chromatography is one of the separation techniques that is used to separate the constituent of a colored substance. The constituent of a colored substance using an adsorbent medium. Adsorbent medium. Are you there? Okay, using an adsorbent medium. So chromatography is a special technique that is used to separate the constituent of a colored substance. Are you there? That indicator solution is a colored substance. Okay, so the component can be separated using an adsorbent medium. An adsorbent medium could be a kind of a paper. Are you there? Could be a kind of a paper. Do you understand? So that's the correct option. But let's look at the other options. Crystallization. No, you don't use crystallization to separate any color substance. Are you there? So crystallization is used to obtain a solid from its solution. It's also another separation technique, but crystallization is used to obtain a solid from its solution. Are you there? A soluble solid from its solution that will decompose on eating. Then option C, distillation, to obtain a liquid. Distillation is another separation technique. It is to obtain a liquid from its solution. A liquid from its what? From its solution. A liquid from its solution. This one is applied in the purification of water, in pure water. Okay. Evaporation. Evaporation is also used to obtain you can use to obtain a solid from its solution. So from a solution, if the solid will not decompose on eating, for example, you are having sodium chloride solution, that is sodium chloride with water, and you want to obtain a sodium chloride from it, you can just eat it. When you eat it, the water will evaporate, leaving the sodium chloride in the crucible, in the vessel. Are you there? So that the sodium chloride will not decompose on eating, but if the solid will decompose on eating, you go with what? Crystallization. Option E, filtration, is used to obtain also you can use to separate a solid from a liquid. Are you there? filtration. You use it to separate the solid from a liquid using a filter paper. Alright, so our correct option is what? Option A. The component of universal indicator solution can be separated by what? Chromatography, because it is a colored substance. We can also, if you want to separate the color constituent of dye, you also use chromatography. Are you there? Use chromatography. Is that taken? Then also, if you see another question that has to do with what kind of separation technique can be used to obtain the green pigment in plants, the green pigment in the leaf of a plant is still chromatography. Are you there? So number 29. Sulfur exists in different forms in the same physical state. Sulfur exists in different forms in the same physical state. This phenomenon is known as option A, allotropy, option B, chromatography, option C, isomerism, option D, isotopy, option E, saponification. Let's analyze option. They said option A, they said going to say sulfur exists in different forms in the same physical state. This phenomenon is known as option A, allotropy. So allotropy is the existence of an element in different forms in the same physical state. Allotropy is the existence of an element either in different forms, but in the same physical state. Are you there? So now sulfur, that's the answer. Do you understand? I just want to analyze sulfur. We have different allotropes of sulfur. Are you there? We have the rhombic sulfur, we also known as alpha sulfur. We have the monoclinic sulfur, also known as beta sulfur. We have the plastic sulfur, and we have the amorphous sulfur. Are you there? Those are different forms by which sulfur exists. We also have carbon. Carbon also exhibits allotropy like that. Different forms of carbon, diamond, graphite, wood charcoal, and all that. Do you understand? That's the correct answer. Option B is talking about chromatography. I've explained chromatography in number 28. C, isomerism. Isomerism is not the answer. So are you there? Isomerism is a process. Are you there? Is a process by which a compound, an organic compound, exists in more than one forms. Exists in more than one form. Are you there? Having the same molecular formula but different structural formula. Having the same molecular formula but different structural formula. Is that taken? Like we can have you can have C2H5OH. Are you there? Which is same thing as C2H6O, right? Carbon 2, hydrogen 5 plus 1, 6, oxygen 1. The same number of atoms of carbon, the same number of atoms of hydrogen, 6 here, the same number of atoms of oxygen, 1 here. So we can take this one as ethanol. Chineke. We can take this one as, this one can be rewritten as CH3. Are you there? You have CH3, that's one carbon here. Are you there? Oxygen, another CH3. That's carbon, that's 2. Hydrogen 3, that's 6. Oxygen 1. Are you there? So we can call this one methane, or dimethyl ether. Are you there? Dimethyl ether or methane. So we can see an organic compound having the same molecular formula but different structural formula. The structure, if I want to draw the structure will be carbon 2 for ethanol, 1 1 1 1 1 4 4. Hydrogen, OH. This is structure. Now look at methane. It will be oxygen like this, double bond, carbon. Are you there? So we have this 1 2, right? So carbon like this. We're having 2 carbons there. Are you there? So we're having 2 carbons. So when we have we can come this way, oxygen, comma, bond, carbon, 1, 2, 3, hydrogen, hydrogen, hydrogen. Are you there? Come this way, carbon, 1, 2, 3, 4. With this one, hydrogen, hydrogen, hydrogen. This is CH3. Yeah, this is CH3. Carbon, the bond around carbon atom must be 4. Are you there? So this 1, this 2, this 3, this 4. Hydrogen 1, 2, 3. Then the bond around carbon atom also here must be 4. That's 1, 2, 3, 4. Then, and this is carbon, right? And we have how many atoms of hydrogen? 1, 2, 3. That's CH3, CH3. Then oxygen at the middle. Oxygen must take double bond. That's 1 and 2. So different structures, but the same molecular formula. That's isomerism. Then option D, isotopy. So isotopy is a phenomenon that occurs either when an atom have the same atomic number but different atomic mass. The same atomic number but different atomic masses. Either. So that's all the answer. Option E, saponification. That's the process by which fat or oil react with caustic soda to produce soap and glycerol. So that's all the answer. So our answer is allotropy. Allotropy. Okay. That's for number 29. It says sulfur exists in different forms in the same physical state. This phenomenon is known as what? Allotropy. Number 30. Let's say which of the following atoms contain the highest number of electrons in its outermost shell? Let me write the options on the board. Which of the following atoms contain the highest number of electrons in its outermost shell? I think we have oxygen, subscript 8. We have argon, subscript 18. So we have phosphorus, subscript 15. We have potassium, subscript 9, 19. So we say we have magnesium, subscript 12. So these are the elements. Which of the following atoms contain the highest number of electrons in its outermost shell? Oxygen, the atomic number there is 8, as we are given 8. Okay, so the outermost shell is the valence shell. The outermost shell is the valence shell. When you look at oxygen will give you 2, 6. The first shell takes 2 electrons, second shell, the outermost shell takes 6 electrons. Argon will give you 2, 8, 8. First shell is 2, second shell takes 8, third shell takes 8. 15, phosphorus is 15, that's 2, 8, 5. The first shell takes 2, second shell takes 8, and the third shell takes 5. Then potassium, 2, 8, 8, 1. First shell takes 2, second shell takes 8, third shell takes 8, fourth shell takes 1. Magnesium, 2, 8, 2. 2 plus 8 plus, that's 12. So first shell takes 2, second shell takes 8, third shell takes 2. Look at all these elements. Which one has the highest number of electrons at the last shell? At the last shell is this man, argon. Okay, argon. So, argon. So that means our correct option is what? Option B. Number 30 is B. 30 is B. 30 is B. Let's go to 31. 31 is a calculation question. Let's see how far we can solve that particular question. The question says, how many grams of hydrogen gas will be liberated when 6 grams of magnesium ribbon dissolves in hydrochloric acid? How many grams of hydrogen gas will be liberated when 6 grams of magnesium ribbon dissolves in hydrochloric acid? Before you can calculate this particular question, you have to write the balanced reaction, balanced chemical reaction, balanced chemical reaction. They say how many grams of hydrogen gas will be liberated when 6 grams of magnesium ribbon dissolves in hydrochloric acid. You have to write the reaction. So magnesium reacting with hydrochloric acid to give magnesium chloride plus what? Hydrogen gas. Are you there? Don't forget that one of the chemical properties of acid is that they react with metal to liberate what? Hydrogen gas. Okay. All right. Is the reaction balanced? Magnesium is 1 year, magnesium is 1 year. Then chlorine is 2 year. Let's put 2 year. Okay, so chlorine is 2, hydrogen is 2, hydrogen is 2, so it's balanced. So you can put the state. This is a solid, this is aqueous, this is aqueous, and this is a gas. Okay, that is practically you see them as a solid, aqueous. As aqueous means in a solution form. All right, so it's balanced this way, right? Now they say how many grams of hydrogen gas will be liberated when 6 grams of magnesium ribbon dissolved in hydrochloric acid. You know, calculation in chemistry has to do with you compare two chemical substances. What and the two chemical substances that you are going to compare depends on what you are given the question. Because how many grams of hydrogen gas? That means I need hydrogen. I need to compare hydrogen. That means I need hydrogen. Will be liberated when 6 grams of magnesium ribbon dissolves in HCl. So they gave me 6 grams of HCl. So I need to compare HCl and magnesium together in terms of their masses. In some questions, it could be in terms of concentration. It could be in terms of any other values or under unit. But this one is in terms of what? Masses. Now, stoichiometrically, we have 1 mole of magnesium that reacts with 2 moles of hydrochloric acid. Are you there? So you use that to get your the final answer. So 1 mole of magnesium. No, there's one invisible one here. So multiplied by the atomic mass of magnesium. The atomic mass of magnesium in the question is given as it should be 24. Okay, that's 24. It's given as 24. So that's 1 times 24. Okay, 24. Then plus 4. Reacts with 2 moles of hydrochloric acid. That's 2 multiplied by. Now let's go and calculate the molar mass of hydrochloric acid. Molar mass of hydrochloric acid. You know, hydrogen is 1 plus chlorine is 35.5. It's given in the question. Atomic mass of hydrogen is 1, chlorine is 35.5, and that gives what? 36.5. So this is 36.5. Okay, so you can put grams, you can put what? Grams. So it means that, so let's it means that 24 grams of magnesium, are you there, react with 2 times 36.5 grams of HCl. Is that taken? So let's multiply this. 1 times 24 grams, that's 24 grams of magnesium reacts. This one, let me use this one as react. This symbol as react, not product, please. That's 2 times 36.5. That's 73. So 73 grams of hydrochloric acid. All right, these are the 2 values that we have compared. This is the first line. You need another line. You always have 2 lines when you are solving calculations in chemistry. 2 lines. Okay, this is the first line. Then the second line. Guess the second line will be from the question. It said, how many grams of hydrogen gas will be liberated when 6 grams of magnesium ribbon? 6 grams of magnesium is given. Look at magnesium here. This side is for magnesium, this side is for hydrochloric acid. So we are putting 6 grams of magnesium here to give how many grams of hydrochloric acid? We are calculating hydrogen. We are calculating for hydrogen, not for hydrochloric acid. Hydrogen. So how many grams of hydrogen gas? So we are comparing magnesium and hydrogen gas. Magnesium and hydrogen gas. So magnesium and hydrogen gas. We are given 6 grams of magnesium, and we are calculating for what? Mass of hydrogen gas. I thought hydrochloric acid. So I think I calculated very well. So mass of hydrogen gas. So we are comparing magnesium and what? Hydrogen gas. Okay. So what is the? You can see that 1 mole of magnesium produce 1 mole of hydrogen gas here. 1 mole of magnesium produce 1 mole of hydrogen gas here. Are you there? After balancing. So what is the atomic mass of magnesium? Is given as 24. 24 grams of magnesium. Are you there? Produce hydrogen, atomic mass of hydrogen is 1, multiplied by 2, that becomes 2 grams of hydrogen gas. Are we together? So magnesium and hydrogen gas. Hydrogen is 1, the atomic mass of hydrogen is 1, multiplied by 2, that's 2 grams of hydrogen gas. Then this one, magnesium, atomic mass is 24, so 24 times 1 gives us 24. Whatever is here was multiplied by the atomic mass. We are just lucky that there's a visible one here. If you have 2 here or 3 here, if you have 3, it's going to be 3 times 24. If you have 2 here, it's going to be 2 times 24. If you have 5, it's going to be 5 times 24. Are you there? The same thing is here. If you have 3, it's going to be 3 times the atomic mass of hydrogen gas added together. Is that taken? Now, to now give us 6, this side is for magnesium, this side is for hydrogen gas. Magnesium this side, hydrogen gas this side. Now, second line, 6 grams of magnesium ribbon. 6 grams of magnesium ribbon. This side is for magnesium, that's 6 grams. 6 grams of magnesium. We give us question mark, mass of hydrogen gas. 6 grams of magnesium. So that question mark, let it be X, any alphabet of your choice. Then you cross multiply. When you multiply and make X the subject, you have S equals to 6 times 2 all over 24. 6 times 2, then divided by 24. And that gives us 12 over 24. Are you there? And that gives us half, which is 0.5 grams of hydrogen gas. So option A is 0.25, option B is 0.50, option C is 0.75, option D 1.00, option E 2.00. You can see that the correct option there is what? Option B, 0.50, which means that 0.5 grams. That is the mass of what? Hydrogen gas. Don't forget, you have 2 lines. When you're calculating anything in chemistry, calculation in chemistry, you have 2 lines. The first line, you get it from the stoichiometry of the reaction. Then second line will be from the values given in the question. Then you compare the chemical species involved. Number 32, a piece of damp blue litmus paper. A piece of damp blue litmus paper was dropped into a gas jar of an unknown gas. The litmus paper turned pink and then bleached. The gas is. This is a practical question that has been experimented in the lab. A piece of damp blue litmus paper was dropped into a gas jar of an unknown gas. The litmus paper turned pink and then bleached. The gas is. Okay. Alright, let's see how we can do that. Option A, chlorine. Option B, helium. Option C, hydrogen. Option D, nitrogen. Option E, oxygen. It's a piece of damp blue litmus paper was dropped in a gas jar of an unknown gas. The litmus paper turned pink and then bleached. So that means you need a bleaching agent. So they want to test our IQ on a bleaching agent. Are you there? So we know in chemistry that chlorine is a bleaching agent. Chlorine is a bleaching agent. Are you there? So when you dip a damp blue litmus paper in a gas jar containing chlorine gas, the blue litmus paper will be bleached. First to pink. Are you there? First to pink, and finally you don't see any color again. That is the action of what? Chlorine. Do you understand? And when you look at it microscopically, when you look at it inward, you find out that it's not chlorine that is performing that function. It's hypochlorous acid that is performing that function. You see when chlorine, look at that word, damp blue litmus paper. It means that the blue litmus paper must have been soaked. Are you there? Must have been put or inserted or immersed in water. They will wet it with water. Water must be there. You must wet the blue litmus paper with water. If you don't wet it, that action of chlorine will not take place. And this, when I put in that gas jar containing chlorine, that chlorine gas, are you there, will react with the water molecule in the damp blue litmus paper, H2O, to give hypochlorous acid plus HCl. hypochlorous acid, HOCl. Is this hypochlorous acid that performs that function you are talking about? Is this HOCl that is responsible for that bleaching action? Is not directly chlorine gas when you look at it very well. Do you understand? So, but we see attribute it to chlorine gas. But when you look at the chemical equation inward, chemical reaction that have taken place in the bleaching action, you know that it's HOCl that is performing that particular function. And that's why we have hypo. Say the hypo. Hypo is used to bleach. Is for is a chemical that is for washing clothes, white clothes, to make it white. Either if there's a stain, it removes it. So they call it hypo from the word hypochlorous acid. So option A is a piece of damp litmus paper was dropped into a gas jar of an unknown gas. The litmus paper turned pink and then bleached. The gas is chlorine. That's answer. Or option B is wrong. Helium, no. Helium is a noble gas. It doesn't have the hydrogen. Hydrogen, no. Nitrogen, no. Oxygen, no. So option A is chlorine. 33. This is another experimental question. An unknown gas with an irritating smell was bubbled through a solution containing acidified potassium heptachloride 6. The solution changed from orange to green. I repeat the question. An unknown gas with an irritating smell. Well, you know, each of these gases in chemistry, they have their own peculiar way of being identified in terms of their color, in terms of their odor, do you understand? In terms of their chemical properties. An unknown gas with an irritating smell was bubbled through a solution containing acidified potassium heptachloride 6. The solution changed from orange to green. You see, acidified potassium heptachloride 6 is an oxidizing agent. When a reducing agent comes in contact with this oxidizing agent, the reducing agent will reduce the heptachloride 6, will reduce the oxidizing agent. Are we together? So we have about 4 gases, are you there, that can turn the orange color of potassium heptachloride 6 to green. Sulfur oxide gas can do that. Are you there? Hydrogen sulfide gas can do that. Ethene C2H4 can do that. Ethine C2H2 can do that. These four gases can change the orange color of acidified potassium heptachloride 6 towards green. Are you there? But when you look at for sulfur oxide gas, when sulfur oxide gas turns that orange color to green, sulfur will not be liberated as one of the products. Sulfur will not be must not be liberated as one of the products. Then for hydrogen sulfide gas, sulfur will be liberated as one of the products. Before that, let's look at the option that we are given. They said option A, they gave us chlorine gas. Option B, they gave us carbon dioxide gas. Option C, they gave us ammonia gas. Option D, NH3, they gave us sulfur oxide gas, SO2. Are you there? So we have option D, sulfur oxide gas. Oh no, option C is option C. We are given option C as hydrogen sulfide gas in the question. Option D as ammonia gas, NH3. Option E as sulfur oxide gas. These are the options. Are you there? As you can see, though C2H4 and C2H2 is not the options, okay, that means we will not analyze this. Are you there? But don't forget that these two also can turn the orange color to green. Now look at SO2 and H2S. Sulfur oxide gas and hydrogen sulfide gas are in the options, option C and option E. The examiner want to test you on something. You see, when sulfur oxide gas is bubbled into acidified potassium dichromate 6, are you there? And the color turns from orange to green. sulfur will not be liberated as one of the products. But for hydrogen sulfide, sulfur will be liberated as one of the products. Sulfur will also turn the color of that chemical, acidified chemical K2Cl2O7, from orange to green. But with the addition, but in the product, sulfur will be liberated for hydrogen sulfide. But sulfur oxide gas, sulfur will not be what? Liberated. Are you there? So, but the question says, through a solution containing acidified potassium heptazochromate does not change from orange to green. They stop there. Does not change from orange to green. They didn't say with the release of sulfur, turn from orange to green. So we go for sulfur oxide gas. Are you there? And then the ground continues and says with the libation of a yellow deposit, which is sulfur. Are you there? So we go for hydrogen sulfide. But now they said they stop at the solution change from orange to green. So our correct answer is what? SO2. SO2. So for us, E. Option E is the correct answer for number 33. Now 34. The major constituent of air is major constituent of air. Major constituent of air. You know, air is a mixture. Air is not a compound. It's not an element. It's a mixture. Are you there? Air is a mixture. And what are the constituents of air? What are the constituents of air? We have nitrogen gas. We have oxygen gas. Are you there? So we have nitrogen gas, oxygen gas, we have carbon 4 oxide gas. Are you there? So we have noble gases. We have noble gases. Are you there? So we also have gaseous impurities. We have gaseous impurities. There are impurities in air, like the particles, you know, the fine sand particles in the air that mix with air. Are you there? So these are the constituents of what? Air. Are you there? So the percentage by volume of this is roughly 78%. Of this is roughly 21%. Of this 0.3%, 0.3%. Are you there? Like that. So if you look at all the constituents, you find out that nitrogen has the highest composition. Is that? So nitrogen has the highest composition, 78%. Are you there? Now the major constituent of air is A, carbon 4 oxide, no. B, hydrogen. Hydrogen is not even one of the constituents of air. Nitrogen, that's the answer. Noble gases. They also have water vapor. Are you there? We also have water vapor. So we have water vapor. Okay, we have water vapor also. So all these are the constituents of air, but the one that has the highest percentage is what? Nitrogen, 78%. Okay, so that's our answer. Okay, so that means option C is nitrogen. Option A, carbon 4 oxide. Option B, hydrogen. Option C, nitrogen. Option D, noble gases. Option E, water vapor. So our correct option is what? Option C, nitrogen, for number 34. Now 35. Which of the following pairs of halogens are gases at STP? Which of the following pairs of halogens are gases at STP? Standard temperature and pressure. Okay, gases at STP. So we have number 35 option. We have option A, chlorine and bromine. Option B, chlorine and fluorine. Option C, fluorine and bromine. Option D, iodine and bromine. Option E, iodine and fluorine. I repeat, which of the following pairs of halogens are gases at STP, standard temperature and pressure? Option A, chlorine and bromine. Option B, chlorine and fluorine. Option C, fluorine and bromine. Option D, iodine and bromine. Option E, iodine and fluorine. You know, all these are halogens, element in group 7. So let's look at the elements in group 7 in the order they are placed in periodic table, in the order of their atomic number. So the first element in group 7 halogens, known as halogen family, is we have fluorine, we have fluorine, we have chlorine, we have bromine, we have iodine, and we have astatine. These are the elements in group 7 of periodic table: fluorine, chlorine, bromine, iodine, and what? Astatine. Are you there? So is fluorine and chlorine Two of them are gases. Are you there? They are gases at STP. Are you there? They are gases at normal temperature and pressure. Are you there? Bromine is water, is a liquid. Bromine is a liquid. Bromine is a liquid. Iodine, understand, they are solids. Are you there? They are solid. Iodine, understand, they are what? Solid. Bromine is a liquid. Fluorine and chlorine are gases at STP. So option A, chlorine and bromine. Bromine, wrong. Option B, chlorine and fluorine. So option B is the correct answer. Chlorine and what? Fluorine. Chlorine and fluorine, they are gases at what? STP. That was number 35B. 36. Which of these compounds will not give oxygen gas on eating? Which of these compounds will not give oxygen gas on eating? The action of heat on some compounds. Which of these compounds will not give oxygen gas on eating? Let's look at the options. Option A, ammonium triazonitrate 5. Ammonium, option A, ammonium triazonitrate 5. Ammonium, that's NH4, are you there? NO3. Ammonium triazonitrate 5. NH4, NO3. When you eat ammonium triazonitrate 5, it decomposes into nitrogen 1 oxide, otherwise known as laughing gas, are you there? Plus H2O. Oxygen gas is not liberated when ammonium triazonitrate 5 decomposes under the action of heat. So it's not oxygen gas is not released. Okay, let's look at option B. Hydrogen peroxide. Hydrogen peroxide is H2O2. In fact, in the laboratory, this is one of the ways of preparing oxygen. Hydrogen peroxide decomposes under the action of manganese 4 oxide as a catalyst to give water and what? Oxygen gas. Can you see oxygen is liberated in this? In the lab, if you don't put the catalyst, it will take time for oxygen gas to be liberated. But you put the catalyst, manganese 4 oxide is usually the catalyst added to speed up the chemical decomposition of hydrogen peroxide into water and what? Oxygen gas. Option C, manganese 4 oxide. Manganese 4 oxide itself as a chemical. When it is heated, it will give us manganese 2 oxide plus oxygen gas. Manganese 2 oxide plus oxygen gas. Because the question says, which of these compounds will not give oxygen gas on eating? Okay. Option D, sodium triazonitrate 5. Sodium triazonitrate 5, and that's NaNO3. Under the action of heat, it will give you NaNO2 plus O2. That is sodium diazonitrate 3. And this is, we said the nitrate, the nitrate of potassium, sodium, will decompose on heating to give nitrite, TRITE, or sodium diazonitrate 3 with release of what? Oxygen gas. So that's sodium triazonitrate 5. The option E, zinc triazonitrate 5. Zinc triazonitrate 5. Zinc will decompose, zinc nitrate will decompose into zinc oxide plus nitrogen 4 oxide gas plus oxygen gas. Okay, like this. So you can see out of all these options, it is only ammonium nitrate that did not release oxygen gas. Is that taken? So our correct answer is A. Number 36. Which of these compounds will not give oxygen gas on eating? Ammonium triazonitrate 5. When you look at the reactivity series, the nitrate of highly electropositive elements like sodium, potassium, decompose to give their diazonitrate 3. That is NO2 diazonitrate 3, maybe sodium diazonitrate 3 or potassium diazonitrate 3 with this oxygen gas. But the moderately reactive elements like zinc, like copper, like lead, they decompose into their oxides nitrogen oxide gas, and oxygen gas. Why the element that is very low in electrochemical series, that their electropositivity is the least, just like below, just like silver, mercury, are you there, gold, are you there? So when it decompose into their metals. For example, silver nitrate will decompose into silver plus nitrogen oxide gas plus oxygen gas. Are you there? And the reason why silver nitrate, mercury nitrate, gold nitrate are given their element is because they can be found in a free state. They can be found in free state. They can easily be gotten from the earth crust. Are you there? Raw like that. Okay. So our correct option is option A, ammonium triazonitrate 5. Number 37. When sodium dissolves in water, the resulting solution is, when sodium dissolves in water, when sodium dissolves in water, that's number 37. This is sodium, Na, sodium dissolving in water. We have sodium hydroxide plus hydrogen gas. Sodium hydroxide plus hydrogen gas when sodium dissolves in water. At this point, you balance all your reactions, okay? You must balance them. So there's no time for that here. So this is the alkali. This is an alkali. Okay? This is an alkali. Option A says, when sodium dissolves in water, the resulting solution is option A, acidic, B, aerosol, C, alkaline, D, emulsion, E, neutral. No. When you look at acid, it's not, this sodium hydroxide is what? Alkaline, a soluble base. So our correct option is what? Alkaline. It's not acidic, it's not an acid. Okay? Aerosol. Aerosol is when a solid or a liquid is dissolved in a gas. A solid or a liquid is dissolved in a gas. Are you there? So just like smog, SMOG in air. That's a good example of aerosol. Okay? Then alkaline, option C, that's alkaline, that's the correct answer. So emulsion, when liquid dissolves in a liquid. Are you there? So the neutral, nothing like neutral as far as this one is concerned. Our correct answer is what? Alkaline, option C. Now number 38. The oxidation state of chlorine in KClO3, that's potassium triacylchloride 5. The oxidations, I haven't said it. Potassium triacylchloride 5. It's KClO3. That's KClO3. They said we find the oxidation state of chlorine in this is what? Are you there? So you add the oxidation number of all the elements and equal to 0 because nothing is there. But if it's like SO4 2 minus, you add the oxidation numbers of all the elements equals to -2. If it is Cl2O7 2 minus, you add the oxidation number of all the elements equals to -2. If it is ordinary ClO3 minus, you add the oxidation number of all the elements equals to -1. But if it's a compound like this, that nothing is here, you equate everything to 0. So what is the oxidation number of potassium? And it is not given, but as a chemistry student, you must know oxidation number of carbon of potassium is 1 plus 1 plus 1. Difference between valency and oxidation number. Valency we have no sign, but oxidation number we have sign, either positive or what? Negative. If you are asked to calculate oxidation number, if this question is an essay question, theory, and you get the final answer as 5, and you leave it like that, they mark it wrong for you. Though mathematically, we know that there is invisible plus there, but the chemists will not take it likely like that. They will not look at it like that. You must put that plus 5 oxidation number. Okay? So now oxidation number of potassium is +1, then plus chlorine. We are looking for oxidation number of chlorine, Cl, that will be unknown. Then plus we are having 3 atoms of oxygen, that means 3 brackets. The oxidation number of oxygen is -2, so all equals to what? Is 0. How did I get the oxidation number of potassium as +1? When you look at potassium atomic number is 19, and the electronic shells takes these electrons 2, 8, 8, 1. The first shell takes 2, second shell takes 8, third shell takes 8, then the fourth shell takes what? 1. So this 1, this last number will be what? Will be released. That this is the valence electron of potassium. It will be donated, it will be released to any element that needs it. It now become octet structure. So that's where I got my +1 from. The same thing with oxygen. I got oxygen number of oxygen as -2. The atomic number of oxygen is 8. Is it? So electronic configuration 2, 8. That means the old electronic configuration, not the one of 1s2, 2s2, 2p6, 3. I'm not using that one now. I'm using this old one. So 2,8. I mean 2,6. 2,6. So this oxygen, the first shell takes 2 electrons, second shell takes 6 electrons. So it needs more 2. It needs 2 more for this 6 to become 8, to become octet. It will accept 2 electrons. It will accept 2 electrons it needs, and that's why its oxidation number is what? -2. When it accepts electrons, it's minus. When it releases electrons, it's what? Plus. So let's solve this one now. So +1 plus Cl plus times minus minus 3 times 2 C is all equals to 0. So we have 1 plus 1 minus 6 plus 1 minus 6 give you -5. Then plus Cl all equal to 0. Then transfer -5 to the other side. So we have Cl equals to 0 plus 5. So we have Cl equals to +5. So this is the oxidation number of chlorine in KClO3, potassium triiosochlorate 5. Okay? Option A +1, option B +2, option C +3, option D +5, option E +7. So the correct option is what? Option D +5. Now 39. Group O elements are unreactive because group O elements, or you call them group 8 elements. Group O elements, or you call them group 8 elements. Are you there? So they are noble gases or inert gases. Option A, say group O elements are unreactive because option A, their highest energy level is fully occupied. That's our answer, by the way. Other option, their melting point increases down the group. That is not the reason. Their melting point increases down. No, group 8 elements do not even participate in any reaction because they have octet or duplex structure. They are complete already. Option C, their atomic shell contains equal number of electrons. No, their atomic shell does not contain equal number of electrons. Are you there? Look at helium and argon. Helium is 2, argon is 18 atomic number. So the electronic configuration old one is 2. I mean the first shell takes 2. For argon we have 2, 8, 8. Are you there? So the last electron here is 8. The only electron here, which is the last electron here, is 2. So the atomic shell of helium has 2 electrons. You got this? So the atomic shell of argon has 8 electrons. So the atomic shell contains equal number of electrons. That's a planted lie. That's a lie. Helium and argon and other things, another element there. So I proved that wrong. D, they are non-metals. Yes, they are non-metals, but that's not the main reason. That's not the main reason why they are called group 0 element. I mean, that is not the reason why they are unreactive. Are you there? Option E, they exist as the atomic molecules. Yes, but that's not the reason. That's not the reason. Are you there? So group O elements are unreactive because their highest energy level is fully what? Occupied. Okay, duplet or octet structure. So 39, option A is the correct answer. Now number 40. What type of bond will be formed when an element with high electron affinity combines with another element with low ionization energy? What type of bond will be formed when an element with high electron affinity combines with another element with low ionization energy? Electron affinity. That is an element that has passion, either to accept electrons. The ability of an element either to attract, to absorb electrons toward itself. That's electron affinity. Are you there? So, and then you see that very well in group 7 elements. Are you there? They have passion, they have high ability to accept electrons. Are you there? Ionization energy, the ability of an element to give out electrons. Are you there? So the energy required, are you there, for 1 mole of an electron, 1 mole of an atom to give out 1 mole of an electron in gaseous state. That is the standard ionization energy. Energy required to give out electrons. Are you there? Electron affinity. Are you there? The ability to accept electrons. Okay, so let's see what type of bond will be formed when an element with high electron affinity combines with another element with low ionization energy. We have option A, covalent bond. Option B, dative bond. Option C, electrovalent bond. Option D, hydrogen bond. Option E, metallic bond. Option A, covalent bonds. Covalent bond, for example, now it can occur it occurs in organic compounds, either, and not only in organic compounds, as it can also occur in other inorganic compounds like carbon dioxide, like gas, and all that. So in covalent bonds, we have 2 atoms. Either the 2 atoms, they share electrons. Either one atom gives out electrons, the other atom gives another electrons, and the 2 of them share the electrons to become duplet or octet structure. That is covalent bond. So they share electrons. Are you there? They share their electrons. That means 2 of them need electrons. That means the 2 atoms need electrons. So since they do not have electrons around them to become duplet and octet, so they rather share. They pair up. They share. Okay, that's covalent bond. Now, dative bond occurs when you have these 2 atoms in which one of the atoms only donates the electrons to be shared. Either you can see that in ammonium ions, NH4 plus. Either you can see that in ammonium ions. So you can also do that in ammonia gas. Okay, for ammonia gas we have nitrogen, we have hydrogen, we have hydrogen. Okay, either. So this one have 1 electron, this one have 1 electron, this one brings 1 electron. Either. So nitrogen has valence electrons 3. Either donate 1 here, donate 1, donate 1. So this one is invariably a covalent bond will occur there. But look at these ammonium ions here. Ammonium ions or hydrogen ions, H3O plus. Either or NH3, we have 4 brackets 2 plus. That is copper 2 tetraamine ions. Either. So these are complex ions where we have dative bond. So it's only one of the elements that one of the atoms that will donate the electrons to be shared. Like for this now, it's only copper. It's only ammonia gas. It has 1 lone pair of electron. It's only ammonia gas that is donating the electrons to be shared in this Cu NH3 complex ions, either, which is deep blue in practically in real life is deep blue in color. Okay, so it's only ammonia gas that will donate the lone pair of electrons to be shared. Now the hydrogen bond. So hydrogen bond is not part of the hydrogen bond. You can see hydrogen bond in ammonia gas. Either in water. More. Either. So hydrogen bond occurs in ammonia gas, water, either, and even hydrogen fluoride than covalent bonds. So hydrogen bond occurs in ammonia gas, water molecule, and hydrogen fluoride than the hydrogen bond that occurs in these molecules are more pronounced than you saying covalent bond. Either. When you look at it very well, you find that they are sharing electrons. Though they are sharing electrons, nitrogen brings electron, hydrogen brings electron, which is covalent bond. hydrogen brings oxygen brings, which is covalent bond. Hydrogen brings fluorine brings, which is what? Covalent bond. Are you there? But for the fact that fluorine, oxygen, and nitrogen, they have high electronegativity values. According to Linus Pauling, Linus Pauling is one of the chemists that that has given out the table for electronegativities of all elements. He found that fluorine, oxygen, nitrogen, they have high electronegative values compared to hydrogen, and that is why the bond, hydrogen bond, is more pronounced in this ammonia gas, water, and hydrogen fluoride than covalent bond. The option E is metallic bond. That is the bond that occurs in every metal. So now let's now look at our final answer. They say, what type of bond would be formed when an element with high electron affinity want to accept electrons? Either combines with another element and that with low ionization energy, that is the energy required to give out electrons. Energy required to give out electrons. So that is option C, electrovalent bond. Do you understand electrovalent bond? You know, whether it's having low ionization energy or high ionization energy, is still giving out electrons. It's still the energy required to give out electrons. So it's still giving out electrons. Are you there? And electron affinity, accepting electrons. So you see electrovalent bond. So another word for electrovalent bond is what? Ionic bond. It's ionic bond. Okay, that's number 40. Number 40 is what? C. Number 40 is C. Okay. Let's stop there as part 2. Then we'll continue from number 41 to 60 as part 3. Okay. So don't forget that this is NECO Chemistry that was written on the 28th of July 2021 here in Nigeria, National Examination Council of Nigeria. Okay, and the explanation will help you to pass WAEC, JAM, you know, and other exams, IGCSE, okay, and all that. So from 41 and from 41 to 60 will be in the third part. Is that taken? All right, thank you so much for listening. Don't forget what I've told you before. Okay,